Hello all, I am Mr. Lee, Chemsir. This video clip is a special gift to my S5 students. Recently, you learned Redox reactions in the book 3B. And then, I found that in book 1, chapter 13, for example, although the topic is corrosion of metals, actually, the reactions involved are all redox reactions. So, this video clip will discuss the relation between these two important topics, and the way to deliver the chemistry concept is expected to be a very distinctive one. So, please listen carefully. For those trivial ideas, of course, I am not going to go through them right now. So, let's start from this page. Do you still remember the essential conditions for iron to rust? You may focus on these 2-3. Yes, when both water and air of course oxygen, are present, then rusting will occur. Then how is the chemistry of rusting about? Again, so early in this chapter 13, you learn that iron becomes iron 2, giving out electrons like this. Right now, I will introduce to you that actually, the process of rusting, as illustrated by this page, can somehow be regarded as a chemical cell. Why I said so? You may find that iron is losing electrons. That means it is undergoing oxidation. And so, this is the reaction that will occur at the anode of a chemical cell. So, I would say that this part or this region may be regarded as the anodic region, because oxidation of iron is to take place here, while the other region, for example here, may be regarded as the cathodic region. So this is the reaction at the cathode. You can see very explicitly oxygen and water, both of them will take part in the cathodic reaction. Of course, this is a reduction. You see, it involves the gain of electrons. So make sure you can identify or visualize the rusting of iron in this way. Next, let's check out this page. Yes, the page talking about rust indicator. Do you still remember this? Rust indicator contains the key component potassium hexacyanoferrate 3, and usually it will also contain the phenolphthalein. I think this photo must be so familiar to you. You are expected to observe the blue color and the red color. Actually, the blue color, as I mentioned earlier, is in fact the anodic region, and the reaction that occurs is just the oxidation of iron to give iron 2. How about the cathodic region? Again, as I mentioned earlier, oxygen and water, both of them will take part to give the hydroxide ions. And of course, once again, what happened in the anodic region is an oxidation, while what happened in the cathodic region is a reduction. And that's why in the anodic region, you will find the blue color, because the Fe2 plus will react with the hexacyanoferrite free ion to give a blue product. How about the cathodic region? There is a pink color. Because of the formation of hydroxide ions, that means this part is alkaline, therefore phenolphthalein will turn pink. So this explains why you will observe the blue and the pink color. Let's go through another part. Do you still remember the cathodic protection? Yes, this is to connect an iron-made object to the negative terminal of a power supply or a battery. So this is the method shown here. So why this can protect iron from rusting? It is because the negative terminal of a battery will give out the electrons. Therefore, in such a circuit, the iron or the iron-made object will be the cathode of the whole setup. And that's why the name of this method is called cathodic protection, meaning that the iron-made object is made the cathode. As the power supply can provide electrons to the iron-made object, therefore, the iron is not going to rust. Next, let's talk about sacrificial protection. Do you still remember how sacrificial protection can be achieved? Of course, we need a metal which is more reactive than iron. Of course, the more reactive metal will lose electrons more readily than iron. Then, making use of such a metal, we can achieve the sacrificial protection. The metal include zinc and magnesium. So let's discuss zinc a little bit. First, using this photo, we can discuss the reactions. Again, if we use the perspective of redox reaction or chemical cells, we can quickly identify that this is the anodic region. So can you write the half equation for the reaction involved? When zinc is being used, of course, this time not Fe to be oxidized. Instead, zinc will be oxidized. While other regions, for example, somewhere here maybe, will be the cathodic region. Again, oxygen together with water will take part, giving hydroxide ions. So this will be the half equation representing the half reaction occurred at the cathode in this example using zinc. Finally, let's talk about using a bag of magnesium to protect iron from rusting. Usually it is used in the protection of iron pipelines from rusting. The same idea applies. Magnesium here being the anode, as it is connected to iron. Iron is the cathode. So magnesium is going to lose electrons to give magnesium ions. Therefore, electrons keep going, flowing along this direction, getting into the cathode. So what will happen at the cathode? Of course, iron is not going to react. Actually, by this setup, we are to protect iron from rusting. So what will react at the cathode? Again, oxygen and water will react at the cathodic region, giving hydroxide ions, and therefore there is no rusting in iron, as iron does not lose electrons. I hope this video clip can help you build up your concept better and better. Thank you for watching this video clip. Bye bye.